Thank you very much. Esteemed speaker. Hello? Hello? Yeah, it's okay. Faculty members of NIT Srinagar, faculty members of VIPS, dear students, a very good morning all of you. So myself Noor Zaman, I am an assistant professor in the Department of Mechanical Engineering, NIT Srinagar. I am here to deliver a keynote talk on advancing sustainable development goal, leveraging lightweight magnesium alloys for climate action. Dr. Manoj Gupta, he has delivered very informative talk on magnesium alloys. So my topic is somewhat closely related to the topic of Professor Manoj Gupta, and he has already discussed about various advantages of magnesium alloys for transportation and industrial applications. So we are already running out of time, so I will try to finish my talk in next 25 minutes. First of all, I will discuss about the NIT Srinagar and some facilities available in NIT Srinagar for 5 to 6 minutes, and then I'll move to the theme of the talk. I'll try to finish the talk by 11:30 a.m. Okay, so I think you can see the beautiful campus of NIT Srinagar, which is established in 1960s, and it is one of the oldest RECs of India. I think it's the third oldest REC of India, and it acquires the status of NIT, which is National Institute of Technology, in 2003. It is situated at the bank of the world famous Dal Lake. So we are having a very nice campus at NIT Srinagar. So I request you all to visit the campus once. And these are some glimpses of NIT Srinagar of my campus. I am enjoying the campus for last 6 years. I joined NIT Srinagar in 2018, October 2018. So these are some pictures of the campus of NIT Srinagar. Yeah, another figure, the left side figure I clicked from my quarter actually. So there is NIT Srinagar is a residential campus. We are having on-campus accommodation. So these are some pictures of NIT Srinagar campus. Now, if we talk about the facilities available at NIT Srinagar, so with my team, with Professor Saad Parvez, with the support of Professor Saad Parvez, we have procured this machine from Germany. The company is DMG Mori India Private Limited in 2020 during COVID. So if I am not wrong, this facility is not available in any NITs of India. It's worth around 5 crores. So what's the benefit of this facility? Generally, if you talk about various applications, various complicated applications, this is an era of the CNC programming. So as Professor Manoj Gupta mentioned, to produce the raw material, to fabricate the magnesium alloy in the form of raw material. So the point is, we need to convert this raw material in the complex and complicated components. So what could be the possible route in order to minimize the energy consumption, in order to improve the productivity? So the route is the CNC machines. Second important application is, if I want to produce the turbine blades, so we cannot produce turbine blade on 5-axis CNC machine. It requires additional 2-axis. So we can produce the turbine blades, we can produce various components for defense applications with the help of 5-axis CNC machine. And the capacity of this machine is, the spindle power is 30 kilowatt, and the maximum RPM is 15,000 RPM. So without wasting time, I'll show you a small video, and then I'll move to the theme of the talk. How can I? Yeah. one more minute is remaining. So I think you must have understood the capabilities of the 5-axis CNC machine. So we can perform even a micro machining for any component by using this machine, and the accuracy of this machine is 6 micrometer. So if you want to produce the micro gears of wristwatch, we can use this type of CNC machines. Now come to the theme of the today's talk, because Professor Manoj Gupta already discussed about the use of magnesium alloy, so I will not focus much on the application. Just to discuss the background of today's talk is, so if you see the left of figure, the earth is split into two halves. One is the green, the thriving portion, another is the dry and the cracked portion. So this is the result of human activities on the health of the planet due to the emissions due to resource overuse. So if you look at various sources of air pollution, starting from the industries, the roads, the agriculture, etc. So we look at the study by the US researcher, and they have claimed around the contribution of the transportation sector is around, it's not clear how much is, 27%. So the contribution of the transportation sector is 27% in air pollution. So due to the emissions like carbon dioxide and methane gas. So what's the impact of these emissions? What's the impact of these greenhouse gas emissions? The impact, the accumulation of these gases will result in the long-term shift in the temperature and the weather condition, which we call as a climate change. So what's the consequence of this? Due to this, the earth is now 1.1 degrees Celsius warmer than the late 19th century, which lead to the melting of the polar ice, which lead to the rising sea levels, etc. So these are the consequences. So what's the solution? How to minimize the emissions in transportation sector? So one possible solution could be the reducing the weight of the vehicle. So all see, if you talk about the people, they generally talk about how we reduce the vehicle, just use the lightweight material. We should utilize lightweight material in some structural applications. But what about the passenger safety? I think you can compare the Swift with the Tata Punch, I guess. So if you talk about the mileage, you get the good mileage in Swift, but if you talk about the 5-star rating, you get in Tata Punch. How to improve the mileage without compromising the passenger safety? So the possible solution could be the use of lightweight material after improving its strength. It means that we should use the lightweight material, but without compromising the strength of the material being used. let's discuss about the 2030 agenda. United Nations, along with the 193 UN member states, they established the Sustainable Development Goal in 2015, and they want to achieve them by 2030, starting from the no poverty, no hunger, goes to the climate change. So the today's topic is to focus the sustainable goal number 13, which is the climate change. So the possible solution could be the use of lightweight material. What's the advantage of using lightweight material in automobile? It will reduce the fuel consumption, it will enhance the energy efficiency, it will improve the productivity, it will cut it short or reduce the carbon dioxide emissions or greenhouse gas emissions. If we take an example, apart from the theory, if we take the experimental example, a 10% reduction in the overall weight of the passenger vehicle, it can result in saving the fuel up to 20 to 30% without significant changes in the design. So I think you can see, just by reducing the 10% weight of the vehicle, we can reduce the 20 to 30% fuel consumption without significant changes in the design. It means that we can use lightweight material for minimizing the emissions, for minimizing the fuel consumptions, for enhancing the energy efficiency. So again, the same discussion, the magnesium having the lightest density with some possible strength. If you see the rolling force and the gradient force, these all are depend upon the mass of the vehicle. So if you reduce the weight, it will ultimately reduce the rolling resistance and gradient resistance of the vehicle. So if we compare the magnesium and aluminum cars with the reference car, suppose a reference car having 100% somewhat weight or 100 kg weight. So if we use aluminum by replacing steel or high density alloy, we can reduce the weight till we can come up with the 64% of the weight. So if we use the magnesium alloys, we can further reduce the weight to 50% in future, not highly being used in future, because research is going on magnesium. We can use magnesium for reducing weight, but research are going on how to improve the strength. So here the challenge is for improving the ductility which is required, because see, if we talk about the Indian market, if we talk about us, we generally look on the performance of the vehicle, of course, but we are focused on the aesthetics also. So in order to get the very complicated, very appearing design of the vehicle, we need to have good ductility of the material being used. And if we talk about the magnesium alloys, they are having lightweight material, but they are not having good ductility to form. It means that they are having poor formability along with the poor tensile strength. So the challenge here is, so if we talk about the mechanical properties, if we increase the strength of any metal, it will reduce the ductility. If we increase the ductility of any metal, it will reduce the strength. But if we talk about our requirement, we require the synergy between the strength and the ductility. It means that we need to increase both the strength as well as the ductility. So this is the graph showing the global fuel economy targets and lightweight production by various countries. In 2016, the Europe target was around 125 gram per kilometer carbon dioxide emission, and they have the target to 2025. Why magnesium alloys? So I won't focus much on this slide because Professor Gupta already discussed about the advantages of magnesium. Magnesium having low density, high strength to weight ratio, excellent castability, high recyclability, good thermal conductivity. Now the problem with the magnesium and magnesium alloys is it's very brittle and having low strength. Pure magnesium, I'm talking about pure magnesium, it's very brittle and low strength. If material is brittle, we cannot deform it. It won't deform, it will break. If it's having low strength, we cannot use for automobile, because we need to compromise, we don't need to compromise the passenger safety. So what could be the possible solution? Solution could be the alloying. So we can go for alloying various elements, aluminum, zinc, silicon, manganese, other rare earth materials, cerium, yttrium, etc., in order to improve the strength as well as the ductility. This could be one of the possible solutions. Magnesium alloy starting from 1932 till 2022. These are possible applications of magnesium alloys currently being used in various applications: the cast helicopter transmission housing, in various thrust reversal cascade casting of Boeing 737, 747 till 767. So these are some applications of magnesium alloys. Limitation: there are not only the property is the limitation, another limitation is the anisotropy. Any idea about anisotropy? If you talk about anisotropy, it means the material possessing different properties in different direction. It depends on the direction of the application of load. Suppose this is the plate of magnesium alloy. If you are checking the strength in this direction, it will be having different strength. If you are checking strength in this direction, it will give you different strength. So this is anisotropy. So if we are using any material which is anisotropic, it will be very difficult to be used in various industrial applications. So there are two limitations. We have to address two limitations. First of all, we have to improve the mechanical properties, which could be the strength and the ductility. Another, how to cope up with the anisotropy. So I think I no need to discuss. I should not discuss the technical content of material science. This is nothing but the slip system of magnesium alloys. Very brief. If you want to deform any material, there are some slip systems. In magnesium, there are three different planes: basal plane, prismatic plane, and pyramidal plane. So if you want to deform magnesium, the basal plane slip system active at room temperature. But other two slip systems are not active at room temperature. It means that if you are deforming magnesium at room temperature, only one slip system is active, due to which you cannot deform it completely. It will lead to formation of micro cracks. Suppose if you are having the pen made up of magnesium, if you want to bend it, it will lead to the formation of some micro cracks. So the target is how to activate all slip systems. If you want to activate slip system, you have to increase the temperature. It should be more than 200 degree centigrade. Now what's the problem? If we increase the temperature of magnesium above 200 degree centigrade, it will lead to grain growth. And if you have ever heard about Hall-Pack relationship, if the grain size is larger, it will reduce the hardness and strength. Due to grain growth, grain size will increase, it will decrease the mechanical properties. So on the see, now you are increasing, you are activating the slip system. On the other hand, you are reducing the strength. But we require to enhance both the strength, ductility, and deformation. So it will lead to poor strength. If it is a poor strength, there is some word which is critical resolved shear stress. Okay. So ultimately, magnesium having poor strength and poor formability even after alloying. So what could be the possible solution? Again, texture. So we can improve the strength and we can minimize the texture. We can enhance the texture weakening. There are possible solutions which are severe plastic deformation processes. Either you go for multi-axial forging, in this direction hammering, this direction and this direction, multi-axial forging. If you are performing forging operation in multi-axis, you can achieve severe plastic deformation. Another could be the accumulative back extrusion, equi-channel angular pressing, and the last is the friction stir processing. And my area is friction stir processing. Okay, friction stir processing, it is a solid state processing method. It works on the principle of friction stir welding, invented by Wayne M. Thomas in 1991 in the Welding Institute, Cambridge. You know the beauty of friction stir welding? Invented in 1991. Before the invention of friction stir welding, in aircraft, in order to join aluminum alloys, they were using rivets, because it is very difficult to join aerospace grade aluminum alloys by fusion and welding, arc welding, gas welding. So if you see, it is very difficult to join these alloys, so that's why they were using rivets, and rivets having their own weight. The target is how to reduce the weight, and if we are using rivets, it carry their own weight. So after 1991, the rivets were replaced by the friction stir welding, and now the Boeing Dreamliner 787, around 70% of welding is being done by friction stir welding process. Now this is friction stir processing, a solid state processing method. It uses a non-consumable tool used for performing the severe plastic deformation. Experimental setup, schematic. Just see the difference in both the figures. Process zone and base material. What's the difference? Process zone and base material. If you can see, the grain size of base material is large. Now after friction stir processing, you can see the process zone grain size. It can reduce the grain size starting from even 80 micrometer to 0.9 micrometer. So if we are reducing the grain size, we can increase the strength and the hardness. These are possible application of friction stir processing. Case study. Okay, I'll move. If you see the microstructure, A figure is the base material microstructure, the B and C are the friction stir processed microstructure. You can see the difference in the grain size. If you see this EBSD, so you can see the difference in the grain size. A is the base material, the raw material, and B and C are the material after friction stir processing, or you can say after severe plastic deformation. The drastic reduction in the grain size, so we can enhance the strength. Micro hardness, tensile strength, you can see base material tensile strength, and you can see the DP tensile strength. This is the conclusion. So 2030 agenda for sustainable development serves a global framework. Magnesium has the lowest density compared to other structural materials. It retains some reasonable strength after severe plastic deformation. And the key challenge in using the magnesium, how to improve the ductility. So it's all from my side. If you have any question, I think I'm on time.